Greetings and welcome back. Today I'm just going to make this very brief video that gives you a review of all of the E2 elimination and SN2 substitution reactions that we've covered up to this point in class. So let's start out with what we did first, which was alkyl halides. So if you have an Rx in which this R, remember this guy has to be sp3. So really what you're looking for is carbon with 3 bonds and a 4th bond to a halogen. We can add any strong nucleophile, and that strong nucleophile can attack the carbon, kick off the leaving group, and you will end up with a new product which now has your strong nucleophile attached to the carbon that was the electrophile. And in that way, we kick off our leaving group by attacking our electrophile with our strong nucleophile. And that is the guts of SN2. And we've done a number of different things with that, but it can really be any strong nucleophile that will do this. When we're trying to do E2 elimination, the requirements are very similar. We need to have a carbon with a leaving group, but we need to have a CH next to that. And if you recall, the way to make sure that we're only going to do elimination and not substitution is to add a strong base that's not nucleophilic. So a strong non-nucleophilic base. We had 3 examples of this. One was that big bulky O-, which usually has a K afterwards, so TBU-OK. Oh, excuse me, TBU-OK. We'll have a K plus right there. The second is LDA. And this one is probably the best one. It's also a little bit more expensive. And that's an N-, so it's an even stronger base. And it's also bulky. The third one, which is a little bit weaker but can often do the trick as well, is just triethylamine. Even though it's neutral, it's still pretty strong. And what all of these guys will do is that they will grab an H on the spot next to the leaving group. So let's ID this. This guy right here is your leaving group. So this guy right here is your electrophile. So that CH right next door is acidic. So a strong nucleophile, or excuse me, a strong bulky base, which is non-nucleophilic, will grab the H off of the neighbor. The electrons holding that H on will become the double bond and allow the leaving group to leave. And in that case, we would always get an alkene afterwards. And that's E2. So one of the new things we talked about was that if you start off with an alcohol, we can turn it into a leaving group by adding tosyl chloride, which looks like this. And a weak non-nucleophilic base, for example, pyridine. And so this whole guy is sometimes just written as TSCl, because there's the chlorine, and that whole big thing is tosyl. And what will happen in this case is that the alcohol will attack the sulfur, kick off the chlorine, excuse me, and you would end up with an H that the pyridine can pull off, and that gives us RO. And sometimes this is written as RO tosyl. But the point here is that this guy right here is a good leaving group. And therefore, essentially at this point, this guy is the same as Rx. And so this can do any SN2 reaction, just like the ones we see up here. So you can do an SN2 reaction starting with an alkyl halide, or you can turn an alcohol into an R attached to a leaving group, which is basically the same thing as an alkyl halide, and then you can do SN2 to that. So the new reactions that we covered is that if you start with an alcohol and you add HBr, you can turn the alcohol into an alkyl bromide. But that reaction doesn't work that well, so we will often instead add PBr3, which turns the alcohol into the same thing, but it does it much better. We can also do this to make an alkyl iodide. To do that, usually we will add phosphorus and iodine, which become Pi3 in the pot, and lets us do the same thing and make Ri. The best way to do this for chlorine is to start with your alcohol, and you can add PCl3, but an even better way to do it is SOCl2, which is thionyl chloride, and that gives us an RCl in very good yields. All right, so these are in general the best ways to turn an alcohol into an alkyl halide. We also looked at the fact that we could start with an ether and add HX. Usually this would be HBr or HI because it doesn't work very well for HCl. We would cleave the ether on both sides, and you would get an Rx, and you would get water, and you would get another Rx. All right, once again, all of these only work if R is an sp3 carbon. All right, and lastly, we saw that we could start with any epoxide, and we had two different ways of attacking it. If you add a strong nucleophile, the strong nucleophile, I'll imagine there's just a lone pair on whatever generic strong nucleophile that is. It'll attack the least substituted side of the epoxide if you add a strong nucleophile, and if you add H plus first, it would protonate it, making that leaving group a really good leaving group, and it would do essentially an SN1 reaction where a weak nucleophile would then attack the most substituted side of the epoxide. So these are all SN2 reactions, and therefore all of these kind of fit into our blanket chapter or section about substitutions. Thank you very much. Bring any questions that you have, and I will talk to you soon.